order to have almost all the services of this application accessible from remote, we used a virtual machine located on Microsoft Azure server. You can access in every moment from any device connected to internet to them because they are running in a continuous way on this server. The REST communication with the server is possible exploiting the highlighted public IP address. Since all the scripts are running on separate Docker containers, we have opened a common port for HTTP communication, that is the number 80. But we assigned a dedicated host port at each service, as we can see from the screen. For example, the host port 8070 is related to the catalog. The scripts running on the server were managed through SSH. They are running separately on Docker containers, but we aggregated them exploiting the Docker Compose tool. We can see on that .yaml file the structure of the system. Each script has a setting file that make any modification really simple. By looking one of them, we can see that all services communicate each other through dummy links. This is possible because through Docker Compose we defined an internal network between the containers. Finally, checking the logs of the container, we can see all the requests made in the previous days and also check in real time the new ones.
It has been realized a simple and user-friendly web form to facilitate the interaction with the service and device catalog. The application is easily scalable because through the web form it is possible at each time inserting new rooms to the warehouse, new users and new devices without limitation. The web form has been developed using HTML, CSS, JavaScript and Python scripts. The web service receives post and put requests from the web form and it sends other post, put and delete requests to the warehouse catalog. The HTML file requires some source JavaScript files and CSS files. It is organized with separated forms for different functions. These forms appear when the dedicated action is selected. The file mywebform.js contains all the functions that spike when a button is clicked. When a button is clicked, an HTTP request is sent to the register.py web service thanks to the use of AJAX. Each room, when it is registered, needs an ID, a code which represents the product type, for example fridge products, frozen products or room temperature products, a temperature range, humidity range and a smoke threshold, which are fundamental for alarms. Registering a room also implies the automatical registration of a new ThinkSpeak channel, where each field it is associated to different sensors. Registering a user implies to choose an ID which starts with M for Warehouse Manager and U for Warehouse Worker. To each user it is associated one or more rooms. Registering a device implies to select a room ID, a unique device ID, a device name, the measure type, the ThinkSpeak field, and the services used for the communication, MQTT or REST. There is the possibility to choose only two services. MQTT is the most used in this project. Updating functions are simple. Each field compiled during the registration phase can be modified later. Let's see how. Then, deleting functions are very easy and fast. When you want to delete a user, a device or a room, it always appears a confirmation pop-up.
This project is based on three types of sensor: a temperature and humidity sensor, a smoke sensor, and a blackout sensor. Sensors are simulated by a publisher and a subscriber. The publisher publishes values at different timestamps. The subscriber receives values and forwards them to TeamSpeak channels and send alarm to Telegram. In this frame, two blackout sensors are shown. They publish data every second. Both publisher and subscriber are updated every 5 seconds. If you delete sensor using the form, both its publisher and subscriber will be removed, and no more values are sent. If you insert again the sensor using the form, a publisher and a subscriber connect again to the broker, and new values are sent and received. Now, let's see how temperature, humidity and smoke sensor works. They are all already connected to the message broker, and so for the TeamSpeak subscriber. This sensor publishes every 15 minutes with a failure probability chosen by the programmer. Subscribers receive values from publisher and forward them to the TeamSpeak subscriber, which will send data to the correct channel. Let's have a look to TeamSpeak. The failure condition is simulated maintaining the out-of-safety range value for several publications. After 30 minutes, 2 values are present in each field of each channel. After 45 minutes, 3 values are present, and after an hour and a quarter, 5 values have been recorded. Not only sensor, but also the catalog is always updated. The system includes functionalities which delete sensor if no publication has occurred. These functionalities work as a subscriber. It receives data published by all the sensors in the platform and updates the last update field in the catalog. At the same time, it checks the last update of each sensor. It sends a request to the catalog to delete the device if there is no update in the last 30 minutes for temperature, humidity and smoke sensor, or in the last 10 seconds for the blackout one. In this frame, you can see how it works. As I shut down the blackout sensor and wait for some seconds, all the devices are removed from the catalog. If I start again, publisher and subscriber, no device is longer present.
Telegram bot exploits the uniqueness of the chat ID of a Telegram account to offer an exclusive registration to the services. Each new user is assigned a predefined user ID that can be of 2 kinds. The M1 is related to the services accessible from the manager. The U1 is related to the services of the workers. When you register from the bot, the chat ID is linked to the assigned user ID, and you are able to access directly to the services assigned to you. You are able also to quit momentarily from the services, but you don't lose anything during this offline period. When you log in again, the system, if some failure happened, will warn you with the specific errors and the timestamp of the failure. Moreover, if you are online, the warning will appear in real time. Manager dashboard, you can see all the services related to this kind of user. Statistics make you able to see all the TeamSpeak statistics of your assigned rooms, which is linked to sensor measurements. Overview gives you a summary of the rooms with all the devices related to them and also the usernames of workers that is assigned to your rooms.
Sensor can send alarms to Telegram. User must register on WareHouse app bot on Telegram with his user ID, which is already associated with one or more rooms. After that, he can log in and so he can have access to all the functionalities and he can receive alarms. Sensors are simulated with a publisher and a subscriber. The publisher sends values according to a certain probability of failures. The subscriber receives the values and retrieves from the catalog the range of normal condition of the room associated with the device. If the value is out of range, the subscriber sends a request to the catalog to find users associated with the rooms and their chat ID. If users are present, the subscriber sends a message with values, normal range, type of sensor, room, users and chat ID. This message will be forwarded to the correct user with Telegram. If an user is associated with more than one room, he will receive alarm from all the rooms, like in this frame. Alarms can arrive from smoke, humidity, temperature and blackout sensor.
The management of the product is done through two different databases. The first database is used to store all the products currently in the warehouse, while the other one is used to store all the products sold. An interface server is also used to provide some statistics about the stored and sold products. The Telegram bot is used to assess all these services. The Telegram bot allows both the users and the managers to see information about the products. In particular, the users can see all the available products in all their assigned rooms. They can enter products in the database of stored products as soon as a new product arrives in the warehouse, choosing the quantity of the item and taking a photo of its barcode. When this happens, a put request is sent to the database of stored products, and the product is stored successfully. Similarly, when they need to sell products, they choose the quantity to sell and take a picture of the item's barcode. When this is done, a delete request is sent to the database of stored products to notify that the products are no longer in the warehouse. When the delete is called, a put request is sent automatically to the database of sold products, so that the products sold are stored successfully. Further information relating to the date of sale of the product is also saved. Both the databases support the GET request, which is used from the interface server to retrieve information about stored and sold products. The managers can see all the statistics on the products stored and sold that are provided by the interface server. The interface server provides many ways to call the GET method, which returns some statistics about the stored and sold products to the Telegram bot. Let us see some of them. All the products in both databases can be retrieved by the Get All buttons, while if more specific statistics are needed, then the Get Sold and the Get Store buttons can be used. When pressing the Get Sold button, managers can choose to retrieve all products sold, get some statistics, such as the average quantity and the total quantity of products sold, or get the most or least sold products. The most and least sold products can be recovered by room, by month, by year, or overall. When an incorrect month or year number is entered, a notification is sent to the user to request the correct parameters. By pressing the Get Store button, managers can choose to retrieve all stored products, get some statistics such as the total quantity and the mode of products stored, or retrieve information on a specific product, or instead get all products whose quantity is below a certain threshold. This is particularly useful for seeing products that need to be repurchased because stocks are running out.